question 6. So, couple of things going on here. First of all, we're told that they both are initially at rest, so that's going to mean that for both of them u equals 0, and we're also told that they're both moving at constant acceleration, so we can just use the normal Suvat equations. So with regard to the distance travelled by A, if we use s equals ut plus half at squared, obviously ut is 0 as u is 0, so we're half times the acceleration of 1.5 times t squared. So the distance travelled by A is 3/4 lots of t squared. Now with regard to the distance travelled by B, it's just going to be half at squared because u is still 0. It's half times 2 times t squared, which is t squared. So they travel for the same amount of time, so these t's are the same t's. Now the other fact that we know is that car A is 100 meters ahead of car B to start with. Okay, so car B is going to catch up with car A. Okay, car B travels the furthest distance. So in order to make them equal, you've got to take the distance travelled by A and add on 100 to get the distance travelled by B. Remember, the distance travelled by B is 100 meters further. So we can, using this down here, so the distance travelled by A plus 100 is the distance travelled by B. Well, we've established up here that the distance travelled by A is 3/4 t squared, and we've established over here the distance travelled by B is t squared. So substituting these two in, we get this. So then taking 3/4 t squared from both sides, multiplying by 4 and square rooting, we can see that they cross over after exactly 20 seconds. Now the question asks us to work out the distance that car B travels. Well, we set up here the distance travelled by car B is t squared, so that's 20 squared, which is 400 meters. Now for part B, we've got to calculate the speed of car B at the moment it overtakes car A. Well, using v equals u plus at, we know that u was 0. We know the acceleration of car B is 2. We've established that the time is 20. So 2 lots of 20 gives us a speed of 40 meters per second.